All right, welcome to the Math 136 live lectures. This is our second session that we're focusing on the midterm review for those of you who are scheduled this week to take your midterm exams because it is week 4. So you should be seeing some slides on the screen right now. You should have been hearing some audio. I had some music playing in the background. If you're not hearing audio right now and you're not hearing me talking, you might want to check the volume on your computer or check the audio settings in your Zoom controls. And if you need help with that, you can call the Zoom tech support line at 1-888-799-9666, extension 2. And throughout the session, and actually let me put this in slideshow so it's bigger for you. There we go. Throughout the session, I really welcome you to participate. You don't have to have a microphone to do that. You can just simply use the chat feature that's in Zoom. You can use the reactions to raise your hand if you have a question and you want to unmute and ask instead of using the chat. But I have multiple screens here. So I have one screen focusing on the Zoom and the chat and one on what I'm going to be working on in terms of the problem. So I should be able to see that if you have questions. This is for you, the students, so I really do welcome your questions because you guys are the ones taking the test and studying, and so we want to help you do that. At the end, I'm going to go ahead and put this in the chat right now, but I'll put it in the chat at the end just in case I forget about it. There is a link to a student feedback form that we would love for you guys to fill out, and I'm putting it in the chat right now. When the session's done, to give us any of your feedback, because this will be continuing throughout the semester and we'll do another one for the final exam. But we have weekly lectures. If you haven't been to any of those, you are welcome to do that. All of that is in the live lecture schedule. Your instructor probably has posted that in your course. Here is a link to it. And then just as a reminder, you do need to be logged into your school Google account to access any of these documents. So I'm going to show you real quickly. This is a sample of what your course might look like. Your instructor might have different announcements here, but we did ask the faculty members to post an announcement. It may not be visible on your recent announcement page. You might have to click on the actual announcements depending on how frequently your instructor posts announcements. So it might not be in this most recent one. And then we did ask, if they wanted to also post a link to it right there on the homepage. So you might have it there. And some of your instructors who are a little bit more tech savvy may have also added it to the calendar or to do so that it shows up there. So I'm just going to pop into this schedule just for a second, just to show you a couple of things, and then we'll dive into your questions and review problems. So you probably have looked at this already, unless you just clicked on the Zoom link that was from your students, from your instructor's course, which is totally fine. But I just want to point out that if when you go in this little icon is just an icon, you don't see a list. If you click on that, it'll show you an outline. So you can just jump to, say, week 4 by clicking on it, and there's less scrolling. So this is where we're at. So you may have also received an email. We asked the help of our marketing folks to send out an email to all Math 136 online students who were enrolled for the second 8 weeks to send them information about this Zoom session, but also to send them the link to the review problems. So hopefully you looked at that in advance, but if you haven't, that's totally fine as well here tonight. And then also a study guide that we put together to try and help you guys as well. So that's linked both here in the schedule. And then you can see that we held a session on Saturday. Some of you may have been at that session, and you can attend any of these sessions because we probably will talk about different things. And there's another session tomorrow from 1:30 to 2:30. So depending on when you're taking your test, you might want to attend all 3 of these. But this is an active link. This is the recording to the one that was on Saturday. So, there might be different problems talked about at the different sessions. So I encourage you to use that if you want to. And then also in your course, there is probably a module that is near the top that your instructor probably has put an announcement out that has some recordings to go with the weeks from first 8 weeks when we did these live lectures as well. So, there are lots of opportunities for you guys to get some help. So I'm going to go ahead and dive into looking at just very briefly, the study guide. I just want to call attention to it to let you know that it's organized by section, and then it refers you to the topics of what you should be able to do. It directs you to a page in your textbook where you can read more information about that if you need to study up on that. And then it gives you some tips and reminders in this last column. Like, don't forget certain things that are common things that we know students forget about, or certain formulas, or like, what does it mean to be in standard complex form? Well, we tell you right here what it is. So you might want to just use this sort of as a checkoff list for yourself to say, okay, do I know this concept? Do I know this section? Yes or no? Or circle things that you need to come back to study, go review in your notes, things like that. I'm not going to read this all to you. You have access to that through the various ways that I showed. But what I'm going to focus on are these review problems. So these review problems we put together to very closely align with the exam. So if you looked at these review problems in advance, you will have noticed that there are 20 of them, and your test is 20 questions long. So this is very comparable to your test. And if you've also looked at this in advance, after problem 20, you will see, it's a very long problem because of all the parts that are in my lab when you print it out. You will see right here, it starts over with question 1, but it's not the question, it's the answers. So what we also encourage you to do is use these last pages that give you the answers, not all the detailed worked out solutions, to check yourself and say, okay, do I know how to do this type of problem? So if you've already looked at this in advance, you may have already said, you know what, I worked on, and I'm just going to randomly pick something here. I've worked on problem 5, and I just can't get this answer. I want to ask about that. So that's what I'm going to open this up to you guys with first. I want to know if you already know, you've looked at this document and you have a specific problem number. Sorry for all the scrolling. Let me just do this quickly. Scroll back up to the top. If you already know you have a specific problem number from this problem set that you would love to ask a question about, I encourage you to go ahead and put that in the chat or raise your virtual hand in Zoom, and I will start taking questions in your orders of you asking questions. Because again, this is about you and you guys preparing to take the test. So I want to go in the order that you guys have questions, not necessarily the order that I want to go through something. So Kemi, I see your hand up, so I'm going to call on you first. And you can unmute, or there you go. I think you're unmuted.
I'm sorry, I'll be back. My kid is crying.
That's okay.
Thank you.
If you prefer to use the chat because you've got some noisy kids, that's totally fine. If you want to talk over the kids, that's fine too. I know how that is. And I know it's prime, like dinner time. Does anybody else, while I'm waiting to see if Kemi unmutes or puts in the chat, does anybody else have a specific problem number or anything that they've looked at in advance? Or is there a particular section that you know you have a problem with? Oh, I see you've unmuted. Go ahead.
Sorry, I hate to be this person. I was paying attention, but I had to sign into my Google Drive because I couldn't access the study guide.
Yeah.
So what document are you looking at right now?
What I'm looking at right now is, and you know what, I can send you guys a link to it.
Okay, great.
Whoops. It is this document that is the midterm review. And let me put that in the chat. And you do need to be logged into your Ivy Tech Google account. So like over here,
Yes,
I'm in
that was
Google
my
Chrome,
issue.
and I'm in my Ivy Tech account. You can see I have many Google accounts, my son,
Yes.
another account, a personal account. So yes, you do want to be in the Ivy Tech one and to view any of these documents. But yes, that's what I'm looking at right now.
Okay, thank you.
You're sure. No problem. You're welcome.
Okay, I'm back.
Okay, yes, Kemi.
Oh, okay. So question 16 and
Okay.
17.
16 and 17?
Yeah, I found the video from the first 8 weeks. That's 16, but I just watched it, and I couldn't get the concept. So
okay, let me go ahead and highlight these 16 and 17.
Thank you.
And I will work them in that order. All right. Okay, and while I'm working on these, If anyone else has other problems, feel free to throw the numbers into the chat, and I'll go in the order that things are in the chat while I'm working through these. And I will go through as many as I can get through. I know we're limited, we only have an hour, but I will do as many as I can. And for some reason, this just kind of half disappeared. And I'm not sure why that is. Give me one moment. I'm going to pause just for a second. All right, so number 16. So it says to graph the following function using techniques of shifting, compressing, stretching, and reflecting. So there's a whole bunch of rules for all of those things. So you can refer either to your notes or your study guide or the module week where you learn stuff about that. So this one function might not use all of those, but I'll try to talk as much as I can about that. So it says start with the basic function of y equals x squared and show all stages. Be sure to identify at least 3 key points. So I see this function, y equals x squared. That is your basic parabola. And so it's going to have the parabola shape. And so you probably learned in, I forget what section it was, but the library of functions. So you had things like absolute value function, square function, cube function. You had all these basic functions, or what we call a parent function. And if you know what that shape looks like, then you can adjust all of them with transformations that alter that basic graph and allow you to do things like stretch a graph, shift a graph to a different location, but it's all going to still resemble that original graph. So we're going to start with that. So this y equals x squared, if I was graphing that, that is centered at the origin. And I'm just going to make a little chart over here. And I'm just going to go out to a couple negative values and a couple positive values. And if I were to square my input values here, when I square -2 or +2, I get an output of 4. And when I square -1 or +1, I get an output of 1. And then when I square 0, I get 0. So this gives me some ordered pairs to specifically plot. I'm going to go ahead and zoom in on this so I can get that a little bit more accurate. So then -1, 1, 1, 1, and -2, 4, and 2, 4. And I could keep going, but that's going to give us the rough basic shape. And I want this to be rounded down here. Okay, so that is y equals x squared. Now, what we need to do, oops, a little bit too small, is we need to figure out, well, what's going on with the function they gave us, okay, according to our transformation rules. So when I look at that, MyLab gives you a multiple choice. So you have to figure out, well, what's happening? Well, anytime you have a number that is in front of what looks like the original function, so notice I've got a 2 in front of the parentheses. I've got a -2 inside the parentheses before it's squared. And then I have a +3 outside of the parentheses after the squaring. So if I were to take away all those numbers I highlighted, the 2, the -2, and the +3, I would simply be left with y equals x squared, my original function, okay? So I want to figure out what all those things do. So when there is something in front, okay, and so I have, I'm going to call it an A, times my original function, then that is going to be a vertical stretch, or I'm going to abbreviate compression. So make it elongated or shrink it down. How do you know? You go by the size of the number. If it's larger than 1, it's a stretch. If it's less than 1, it's a compression. So this is larger than 1. So this is a vertical stretch by a factor of 2. Everything's going to be doubled, okay, vertically. So I can look through my answers and I say, okay, so this says vertically compressed, so I know it's not that. This says vertically compressed, so I know it's not that. So now I see vertically stretched by factor of 2. Okay, it could be that. And then D also has that, so it could be that. So now I've already narrowed myself down to C and D, okay? So then I see that I've got x minus 2 in parentheses and then squared. So for that, if I have my function and inside the function, inside the parentheses, I have what we call x minus h. If I have something that's x minus and then I've got this h value here, that's telling me I have horizontal movement. So this is a horizontal, forgive me for any sloppy handwriting here, horizontal shift. And it's either left or right, okay? So how do you know which one it's gonna be? Well, you have to look at this and basically think of it as whatever symbol you see a minus, do the opposite. So when you see minus, your brain is going to think, let's go to the left, because that's where negative values are or minus values are, but you don't actually do that. So if you see x minus h, your brain says to go left, do the opposite, you go right. Pen's a little glitchy, go right. But if you see x plus a value, your brain is going to say, oh, plus, that's to my right. Do the opposite. So in this case, go left. So what do we see? Well, we see minus 2. So that is going to be, I'm going to abbreviate, horizontal shift right 2. So I come back down here and I see horizontally shifted to the right by 2. Okay, that could be it. Horizontally shifted to the right by 2. Well, that could be it too. So it looks like we're going to be down to that third number to determine which one is which. So we've taken care of that. So now we're down to this plus 3 at the end of my function. So at the end of my function, well, what does that mean? Well, if you have something that is your entire function and then what we say plus k or minus k. So if I see plus k versus minus k, this one is all about vertical movement because it's added on to or subtracted from your entire function, and your function represents output values which move your values up and down along the y-axis. So this is what you see is what you get. That's what I explained to students. So in the previous one, I say, go against your gut. So your brain sees minus, you want to go left horizontally, you don't, you go right. And then vice versa for the one I just did with the H. But this one, if you see plus, you want to go towards plus, which is up. And if you see minus, you want to go towards minus, which is down. So what you see is what you get. You don't go against what your gut thinks you should do. So this is going to be up k units, and this other one with minus k is going to be down k units. So that means for us, we see a plus 3. So that's going to be up 3 units with a vertical shift. So I compare my answers, vertically shifted up. Yep, that's the one. This one says vertically shifted down. Nope, I don't want that one. So that tells me my answer here is C. Okay. So again, not every function is going to have all of those things, but it could. Now, what this doesn't have that could be another type of transformation is there could be a minus sign that's either in the front or on the inside of the parentheses. If the minus sign is in the front, of your entire function, it's saying take the y value, make it opposite. That means something that's up above positive flips to something down below negative and vice versa. So that is a reflection over the x-axis. Whereas instead, if you have f of and you have a negative inside the parentheses with the function with the x's, then that's saying make the x opposite. Well, x runs left and right. So that means take whatever you had and make it opposite. So if you were on the right, you flip it over to the left. If you were on the left, you flip it over to the right. That's flipping and reflecting over the vertical y-axis. So that is a reflection over y-axis. Okay, so just the problem could have that. This one doesn't, but it could. So we've got that narrowed down. So then it says, use the graphing tool to graph the equation. So in MyLab, you probably know by now from doing your homework, you'll get a little box that shows up. And that box will have a little box for a reflection, and then it'll have some sliders for shifting. And you move the little slider either left or right or up or down. And then it'll have a little box that you can put in for stretch or compression, either vertically, and again, sorry for the sloppy handwriting, or horizontally. And then you put in the number. So like if this was a vertical stretch, I would do the vertical box and I would put in a 2 because we said it was vertically stretched by 2. And then we said it was shifted horizontally to the right by 2. So whichever one says horizontally, I would move my little slider until it, said 2. And then if there was a reflection, I'd check the box. So in MyLab, it's a little different than what I have here on the screen. In the screen, I would just have to draw it. But you're going to have the little toolbox that shows up in MyLab that you select all those various things or move the sliders. So then it says, fill in the missing coordinates of the points that lie on the graph for the original function and then corresponding to the new one. So this is where the little chart I made at the beginning is useful. So it's giving us an input of -2, an input of 0, and an input of 4. So I know that what I need to put in those boxes are an output of 4, 0, and 4 for the original function. So right here for the original function, I know the original output is 4 for -2, 0 for 0, and 4 for +2. Okay. Now, for the new function, it says to type your ordered pair. So I'm not putting in just the output, I'm putting in the whole ordered pair. And so what I need to see is where did this point 0, 0 get moved to? And I'm going to start with the 0, 0 in the center. So where did it get moved to? So what I can do is go back up to this chart. I'm going to make a new chart. And my new chart is going to resemble the different things that are happening to the function. So if I think about being vertically stretched, that affects y. So in my chart, the y value is vertically stretched by 2, meaning it's multiplied by 2. Then we said it was shifted to the right by 2. Well, that affects x. So I would add on 2 to move it to my right, okay? And then we also said it was shifted vertically up by 3. Well, that affects y. So after it's doubled and multiplied by 2 to vertically stretch it, it would get 3 added onto it. So all you have to do is take the original coordinates for x and y and do those operations to it. So -2, I add 2, gets me 0. The 4, I multiply by 2, which is 8, and then I add 3, and I get 11. And then I'm going to do the same thing for 0, 0, and 2, 4. So 0 for the x plus 2 is 2. 0 for the y times 2 is 0 plus 3 more is 3. And then for 2, 4, 2 for the x plus 2 is 4. The 4 for the output y times 2 is 8 plus 3 more is 11. So I know the ordered pairs I need to write here down in the boxes that would be there for MyLab is type ordered pair. So I'd have to have my parenthesis, and I'd have to put in 0, 11, close my parenthesis. Then I'd have to put in the 2, 3 in parentheses, and I'd have to enter in the 4, 11 for parentheses, okay? So you follow what the transformation is telling you, and you just do that same arithmetic, either to the x if it's something horizontal or to the y if it's something vertical. Then it says, let's figure out the domain and put our answer in interval notation. And let's figure out the range and put our answer in interval notation, okay? So if our graph started out looking like this parabola up here that I drew in black. Its domain is everything from left to right. I can put any x values into that, and this parabola will just kind of start continuing to still expand out indefinitely. Well, if I vertically stretch it, it doesn't affect anything horizontally. And if I shift it to the right, that doesn't affect its ability to still cover every value. And if I shift it up, it still doesn't affect its ability to cover every value. So its domain doesn't change. Down here, I still have everything from negative infinity to infinity that can go into this function, okay? For the range, this is a little bit different though. We're taking this parabola and we're gonna vertically stretch it by 2, okay? And then we're gonna shift it to the right by 2. So it's gonna move to the right and it's gonna vertically stretch up. But then it's gonna move up vertically, a shift by 2. So every point is, by 3. Every point is gonna move up 3, including this vertex. Let me zoom in on that. So that vertex is gonna move up to 0, 3. Well, actually it's not, it's gonna move to the right 2, so it's gonna be at 2, 3. So it's gonna move to the right and up, it's gonna be at 2, 3. So the bottom of my parabola, which again, like I said earlier, you're graphing this in MyLab, so it's gonna, you're just gonna use the tools and it's gonna plot it for you. But the bottom of this is now at 2, 3, which means domain-wise, which domain runs up and down, it doesn't start until I'm at 3, and then everything above that. So my domain here, sorry, not my domain, range, I misspoke. My range here starts at 3 and goes to infinity because of the way it was shifted up. And that's where the bottom of the parabola was. So that's how I would do number 16, okay? Again, with the little variations of using the tools in MyLab. All right, then number 17, I will go on to next. And if anybody has a follow-up question on anything I just said in that problem, please let me know. Number 17 was asked next. And then I see a few more in the chat. So I will, again, will go in the order of how they were asked. So analyze the polynomial function f of x equals x plus 4 squared times 1 minus x. And this has multiple parts to it. Okay, so what I see here is, first of all, I like to rewrite this because I don't like this in the reverse order, okay? So I am going to rewrite this as x plus 4 squared times negative x plus 1. Okay, so I want to have my x's at the beginning. So I have a negative x plus 1. So this says to determine the end behavior of our graph. And it says that this graph of f behaves like y equals blank for large values of x in absolute value. So what this means is if you were to go out to the very end of your graph, where does the end of your graph point? So this is a polynomial. Polynomials are nice, smooth, continuous curves that can go up and down, and the ends of them are always arrows. And those arrows are either going to point up or they're going to point down. In other words, they're either pointing up towards infinity or down towards negative infinity. And they could go both up, both down, or split one up, one down in either direction. So that's your job to figure out how that works. Well, it depends on what the first term would look like as a power function if this was expanded out. So what do I mean by that? I mean, if I were to take and multiply out x plus 4 squared, I'd have x plus 4 times x plus 4. The first product I have would be an x squared. And then I'd have some other terms. So this would eventually become an x squared times, or plus a bunch of other terms that I'm just going to ignore for the moment, and then times a negative x plus 1 for this other factor. Well, then I would take my x squared and my negative x, and I'd multiply those together, and I'd get a negative x cubed plus a bunch of terms I don't really care about at the moment. So what I'm looking at is that first term if I expanded this. And I'm looking at the power and I'm looking at the sign in front of it, positive or negative. So I see that it's an odd power. And I see a negative sign. So what that tells me is my options are to have, if it's odd, up on the right, down on the left, or the opposite, up on the left, down on the right. Well, this value in front is called A. If A is greater than 0, in other words, it's positive, it's going to be down and then up, like x cubed. And then if A is less than 0, meaning it's negative, then it's going to be the reverse. It's going to be up and then down, like negative x cubed. So it's going to be like this one on the right. Well, it wants an equation. The equation is that power function. It's going to be negative x cubed. Okay. Now, if I had some coefficients in here, like if I had, I don't know, like a 3 in there, well, then there'd be a 3 in here that eventually would come down in front. And so then I'd have minus 3x cubed. But right now I don't have any coefficients other than a 1, so I don't really need that 3. So I'm going to actually get rid of that. But hypothetically, again, you could have variations of these types of problems on your test. If you saw one with a coefficient, you would include the coefficient. So then the next thing says, let's find the x and y intercepts of the graph. And they're separated. So there's x-intercepts and then there's y-intercepts. So the x-intercepts, you take your individual factors and you set them equal to 0. So I see that I have a factor of x plus 4. So I set that equal to 0 and I get negative 4. I see I also have a factor of negative x plus 1. So I set that equal to 0. So I subtract 1, divide by negative 1, and get x equals 1. So it looks like I have 2 x-intercepts. Now, pay attention to the instructions. It says, use a comma to separate answers as needed. Type each answer only once. Well, negative 4 and 1 are 2 different numbers, so they're different. So I need to list them both. And because there's more than one, I put a comma in there. And it just says the intercepts is or are. I don't have to put any other typing with it. I just list the numbers. I don't put x equals, okay? I just list the numbers negative 4 and 1 with a comma, and the order does not matter. I could list 1 first and then negative 4, or negative 4 and then 1. I'm going to put negative 4, comma 1. No parentheses. It's not an ordered pair. Just literally the numbers. Then the y-intercept. The y-intercept is when you put 0 into your function. So that means I want to evaluate f of 0. So when you find the x-intercept, you set the factors equal to 0 or the output to 0. And when you find the y-intercept, you put the input as 0. So if I had a 0, I'd have 0 plus 4 squared. My mistake there. And then negative times 0 plus 1. So 0 plus 4 is 4 squared. That's going to be 16. And then negative 0 is just 0 plus 1 is times 1. 16 times 1 is 16. So it looks like the y value, which says to simplify, type an integer or fraction, and I only have one of them, is just 16. Again, no y equals, just the number 16. Okay. That's part B. Then part C says to determine the zeros of the function and their multiplicity, and use this information to determine whether the graph crosses or touches the x-axis at each of those intercepts. This has a lot of different parts to it. So first of all, it says the zeros is or are. And notice the instructions again. Type an integer or fraction, simplify, use a comma to separate them, type them only once. So hopefully you remember that x-intercepts and zeros are the same. It's just 2 different pieces of terminology that mean the exact same thing. So you already know the answer. It's negative 4 and 1. So I put those in. Okay, so x-intercepts, zeros, same thing. So now it says the lesser zero, and this is where you got to be really careful. The lesser zero of the function is of multiplicity blank, so that the graph of f will either touch or cross, is what this little number 1 is saying down here. So touch or cross the x-axis at x equals blank. But then the other one says the greater zero is of multiplicity blank, so the graph, again, down here, it's labeled number 2, either touches or crosses at x equals blank. So I have 2 zeros. Which one's lesser, which one's greater? -4 is smaller than 1. So -4 is the lesser zero they're referring to. They write it that way so they're not telling you what the answer is. So they just refer to them as the lesser and greater. So that means the x-axis at x equals -4, and the greater zero is going to be the x-axis at x equals 1. Now I just need to figure out their multiplicity and whether they cross or touch. So the multiplicity is the power on the factors. So back up here, I have a 2 on the factor of x plus 4. That gave us the 0 that was x equals -4. So its multiplicity is 2. That's even multiplicity. The -x plus 1 is the factor that gave us the 0 x equals 1. And so that, I'm going to write it, but it's invisible. There's a 1 there. And the 1 is an odd multiplicity. So depending on whether you get even or odd, it tells you whether the graph is going to cross or touch. If you get even, then that tells you that at that x-intercept, it is going to touch the x-axis. And if you get odd, it's going to tell you that it crosses the x-axis. So now I just got to put that in the correct blanks. So the lesser zero of x equals -4 had a multiplicity of 2. And because that was even, it was going to then touch, or I guess it says touches. It would be a toggle in my lab, but because I printed it, I have to write it in. And then the greater zero had a multiplicity of 1, which was odd. So it's going to be so that the f crosses at x equals 1. Okay. All right. Because I see a lot of students miss points on this because they just get stuff in the wrong boxes. Right? There's so many boxes there to put info in. Just, pay attention to which ones you're putting it in. So then it says determine the maximum number of turning points. Okay, so turning points, max number, and it says type a whole number. So the turning points is always whatever the power or the degree -1, or the power for the degree is n, and then we say -1. So if this was all multiplied out, remember we said the first term would be a -x³. Well, that degree is the n value. That's 3. So that means for this function, we have 3 for the power that is the degree -1, which is 2. So the maximum number of turning points where it could have an increase where it could have a max or a min and it turns directions, those are turning points. The most it could have is 2 when it's power 3. And then part E is put it all together and make a graph. So obviously in my lab, a lot of the graphs are multiple choice, so that does help you narrow things down. So remember we said that it was going to be up on the left, down on the right. So that automatically gets rid of A and D. So then we're down to B and C. And so from there, you can look at the zeros and is it crossing and touching at the right place? And so remember we had zeros of -4 and 1. And so I don't even see any zeros that are negative in B. So I know that's not right. And if this is -20, then these are all 1, 2, 3, 4, 5. These are all by -4. So there's my -4 and it's touching. and there's my 1, and it's crossing. So I know that that's my graph. And if I had to draw it, on my paper, I could also draw it like that. Okay, so that is number 17. Kelsey, do you have a question about this one or something else?
Yeah, it's about this one. Could you remind me again how you determined the direction of the graph? I remember you mentioning earlier and I kind of like lost it all.
Like the end behavior at the beginning?
Yeah.
Yeah. So what I did is I pretended that I was going to multiply out all of this with the factors. And so if I had x plus 4 squared, then that would have eventually given me an x squared at the beginning, and then I'd have some other terms when I distribute. But I want to focus on the beginning. And then I'd take that result and I'd multiply by this other factor that I still have. And so by the distributive property, first term to first term would give me negative x cubed, and then a bunch of other terms that, again, I don't care about. I just want that highest term at the beginning. And I'm looking to see, do I get an even or an odd power? And is the beginning positive or negative? Okay. And if it's odd, it's going to be one of these two. They're going to be split. Okay. Split ends, like hair, split ends. Okay. But you look at the beginning sign, is it positive or negative? And that's how you know which one it's going to be. If it's positive, it's down first, then up. If it's negative, it's up first, then down. Now, if these were even powered instead, then your ends would either be both up or both down. And again, you look at the A value. If it's positive, they're going to both be up. And if the A value is negative, they're both going to be down. They go the same direction. Okay. And those are the only 4 options. All right. Okay. I'm going to go in the order of the chat. So I see number 11. Let me get to that. Number 11. Oh, great question. I've seen, whoops, meant to highlight, not cross out. I've seen lots of people ask questions about this and get tripped up on some things with this. Number 11, 1, I'm going to highlight it now here for myself. I'm going to try and get these all in. I know we only, again, have an hour. And 19. Ooh, 19 is a long one. I'm not sure I'm going to have time to get to 19, but I will do my best. I know that that's a graphing one, and I know it's long from memory. Yeah. Okay.
Sorry.
Yeah.
So number 19, Paul Kemba actually went over that, the last live section we have. So
yes.
If I'm not sure the person asking after 19, but if they watched that recording, he actually explained it very well.
Oh, thank
Yes.
you. Okay.
And thank you for mentioning that, Kemi. Yes, I was going to mention that. So let me get to number 11 here. Yes. So on the Saturday recording that's right here, this is in the live schedule that's linked in all of your classes, and you were probably sending an email. In that recording, he did problem 20 and 19 is very similar to it. So we kind of talked about both of them at the same time. And he did number 8. So that's in the Saturday recording, because again, they were really long problems. So that's why he only got through 2 problems. So yeah, so if I don't get to number 19, Amber, and anybody else who is interested in it, I encourage you to go back to this Saturday recording, and I think that'll help you. So I'm going to go with 11. And this is another one. I said this is a great question because I see, again, a lot of students miss points on this question, primarily because they just don't know how to enter the information. Like, I'll look at their work on their paper that they submit with the test, which hopefully you guys all know from looking in your course that you should be writing out your work on paper while you take the test. Your answers go in the computer, and then your work, either you will be scanning it and uploading it into your IvyLearn course for your instructor, like if you're taking a remote appointment, or if you're at a testing center, the testing center will collect it, they'll scan it and they'll email it to your instructor. And then your instructor reviews that for partial credit. And this is one of those questions where all the time I'll see somebody have something correct on their paper and they just didn't know how to get it into the computer in the way that is the correct notation and things like that. So great question. So let's run through these parts. So we are given this function, f of x equals 4x squared minus x minus 3. And the first question we are given is this a. Is the point -2, 15 on the graph of f? Well, if it is, then that is a set of coordinates x and y for the graph. Now remember, y is the same thing as your output f of x. So this f of x is the same thing as what we call y. Okay, it's just that we name it f of x when it's a function. So what I want to do is say, if x is -2, is y 15? So all I have to do is plug in -2 into f and see if I get 15. If I do, it's a point on the graph. If I don't, it's not. So I plug that in. And so that is 4 times -2 squared minus negative, you know what, I'm going to write this in a different spot so I don't go into my answer blank over there. F of -2, I'm looking to see what do I get. So 4 times -2 squared minus -2 minus 3. So I do my arithmetic, follow order of operations, PEMDAS. So square the -2 first, multiply by 4. When I subtract -2, I'm really adding 2, and then subtract 3. And if I do all that, I get 15. So yes, I do get that. So I have to look at my answer choices, and I need the ones that say yes. So it's not A, it's not D. But why is it yes? Because substituting x equals 15, we did not do that. We substituted x equals -2 into the equation results in 15. That's what we did. So we know it's not B and it is C, okay? So that's where, again, I'll see students look too quickly and they'll say, oh, yes, and they'll check B, but they don't read the rest of it to realize that, well, the rest of it doesn't actually work with what it says. So then part B says, if x equals -1, f of x equals blank. Simplify your answer. Well, this is just like what I just did. I just need to plug in an input value and see what I get as an output. It's just phrased differently. So A and B are really having you do the same thing with a different number, but it's just asked differently. And I know that's confusing sometimes to students to say that, you know, here's these two different statements. Why do they have to be phrased differently? Even though they're testing the same thing. But that, you know, math is like that. There's a lot of different ways to ask things and give information. So we're going to go ahead. So this was A. So we're going to go ahead for B. I'll do this in a different color. We're going to take f of -1. So 4 times -1 squared minus -1 minus 3. Same thing, I'm going to follow order of operations. I'm going to do my power first, then I'm going to multiply by 4. I'm going to subtract -1, which is like adding 1, and then subtract 3 and see what I get. And I get 2. So that tells me that, therefore, and if you've never seen an instructor do this, 3 dots in a triangle means therefore, shorthand. Therefore, f of x equals 2. So I'm going to put in 2 because they already have f of x in the box. Notice I'm not using an ordered pair. And that's where I see sometimes students go wrong. They want to write -1, 2 in parentheses, and it doesn't say to write an ordered pair. Okay, so if it did, then you would do that, but it doesn't say to do that. So then it says, using the information in the previous step, that's here, list the points, or point, if there's only one, on the graph where x equals 1. Now it says, type an ordered pair, okay? So now you're taking the input and the output and bringing them together in an ordered pair. So now that is an input of -1 and an output of 2, okay? So again, I know it can be really confusing and stressful, especially if you're like nervous at the test and you just want to get answers in somewhere, but you really got to pay attention to these little parenthetical instructions that are there that add extra information for you. So that's part B. So then let's look at part C. Part C says, if f of x equals -3, well, remember f of x is y. So this is like saying if y is -3, so the output is -3, what is x? So we have to find that and then follow it up with what pointer points are on the graph. So this is the opposite of what we were doing. So now, if f of x equals -3, we're saying if y, which is the same thing as f of x, equals -3, find x. So my equation was f of x, excuse me, equals 4x squared minus x minus 3. So I'm going to take -3 and I'm going to swap out the f of x and put -3 in its place because that's what it's being replaced with. And I'm going to set that equal to 4x squared minus x minus 3. And then I'm going to solve for x. So then you have to think, well, what is that? Well, that's a quadratic equation. Okay. So that goes back to, I want to say like section 1.2 or 1.3 in like the first week of the course. So this is the quadratic equation. So we're going to set equal to 0. So I'm going to add 3 to each side to make a 0 on the left. And that gives me 4x squared minus x and then plus nothing. So I can just write that as 0 equals 4x squared minus x. And then to solve a quadratic equation, you can always try factoring first, because that's going to be the most efficient way if it works. If that doesn't work, you could try the square root method. That would only work if you don't have a middle term. In this case, we have a minus x, that's the middle term. The end term is the constant 0, and then the beginning term 4x squared. Or you could use the quadratic formula. I think quadratic formula would be overkill right here. It's going to be more work than what you need. Notice each of these have at least one x. So we're going to solve this by factoring, by taking out a common x, leaving me with 4x when I divide it out of 4x squared and minus 1 when I factor it out of minus x. So now we use the zero product property to say, if the product is 0, then either one of these has to be 0. That's the only way the product's going to be 0. And now I've got linear equations. Well, this one's already solved. So then I just continue doing opposite operations to solve this one, and I get those two answers. So it said on C, use a comma to separate answers if needed. Well, I have two answers, so I'm going to have to separate them. So 0 and 1/4. And it already has the x equals. So I just have to put in 0, comma, 1/4, or I could put in 1/4, comma, 0. The order should not matter, okay? But I don't need to write the x equals because it's already there, okay? Then it says, use the information in the previous step, list the point or points where this happens. Now again, it says type an ordered pair, and it says use a comma to separate answers. So each ordered pair is an answer. So you're going to have lots of commas. You're going to have the commas in the ordered pairs, and then you're going to have a comma between the ordered pairs. So remember, the output was -3. So the input of 0 goes with -3. That's one ordered pair, comma, and then the input of 1/4 that we solved for x would go with the output -3 also. So I'd have those two ordered pairs separated with a comma representing those points, okay? Then in D, it says, what is the domain of the function? So this is a polynomial. For polynomials, it's always all real numbers. Notice it says interval notation, so -infinity to infinity. So because it's a polynomial, there's no restrictions, okay? Then E says to list the x-intercepts, if any, of your graph. So your x-intercepts you would get when you set the function equal to 0, okay? And so solve your x-intercepts. Do I have room down here? Yes, I do. Okay, so this is part E for x-intercepts. Set f of x equal to 0 and solve for x. So I'd have 0 equals 4x squared minus x minus 3. Well, that's again a quadratic, so I would try to factor. So I'd have 0 equals something times something if it factors. So you could play around with this. You could use the AC method. You could use guess and check. If you know any other fancy methods that a past math instructor may have taught you for factoring, there's a whole bunch of different methods for factoring. You could use any of those methods. And so you figure out that you could use 4x plus 3 and x minus 1. How do you know if it's right? Because you can always FOIL it out and check it. So if I were to multiply my first terms, I get 4x squared. If I multiply my last terms, I get negative 3. And then if I were to do my outer and inner terms together, negative 4x and plus 3x would give me negative x in the middle. So that's how I know I've got that factored correctly. So now I can set each of those equal to 0 and be on my way with these linear terms to get my 2x solutions. Add 1. And so I get 1 equals x. So it looks like I have these two solutions for x. And so the question was, what are the x-intercepts? I have two of them, 1 and negative 3/4. So I go back up here and it says to use a comma to separate these and type an integer or a simplified fraction. So I've got negative 3/4. I'm going to use it as negative 3/4. I'm not going to write a decimal. So I'm going to have negative 3/4 comma, we said 1. Okay. Then, and I would select that box, that little circle for A. Okay. Then for F, list the y-intercept, if any. So the y-intercept is when x equals 0, find f of 0. So f of 0 would be 4 times 0 squared minus 0 in place of x minus 3. That's 0, that's 0, so this is all negative 3. So the y-intercept is negative 3. And so I don't need to use a comma because I only have 1. It's an integer, it's negative 3. I select that, and there I go. And that's how I would do number 11, okay? I think, let's see how long number 1 was. I think I might be able to squeeze number 1 in. Yeah, all right, using the quadratic formula, I can squeeze it in. We might go over a minute or two. I think we'll be all right. So use the quadratic formula. So first of all, you have to know the quadratic formula. You do have a formula sheet for the test. I can't remember if it's on there or not. The quadratic formula is something you should really know. Yep, it is on the formula sheet. So you're in luck. It's on the formula sheet. But it's really a good thing to have memorized anyway, because you use it so much in math. So quadratic formula. Solving for x is opposite of b plus or minus square root of b squared minus 4ac all over 2a, assuming that you have a function that is of the form ax squared plus bx plus c. So that tells me for this function that I have an invisible 1 here. So a is 1, b is negative 4, and c is also negative 4 when that's set equal to 0. So I would have x equals the opposite of b, which is negative 4, plus or minus square root of b squared. So that's negative 4 squared, plus or minus 4 times a, which is 1, times c, which is negative 4, all divided by 2 times a, which was 1. And now I need to simplify this. So work underneath the radical first and the bottom and in front of the plus minus. So this would be equals positive 4, because the negative of the negative, And then squaring -4 is positive 16. And I didn't mean to write plus minus here. I meant to write minus. I already had my plus minus in front of this. Apologize for that. 1 times -4 is -4, but then I'm subtracting a -4, which is really adding 4 all over 2 times 1, which is 2. So 16 plus 4 is 20 over 2. Now, 20 is not a perfect square. You can't take the radical, the square root of it. However, 20 20 is 4 times 5. 4 is a perfect square. So I can rewrite this as 4 plus or minus square root of 4 times square root of 5 over 2. I can break it into 2 radicals of the 2 factors. And now square root of 4 breaks down to 2 times square root of 5 all over 2. And now I always tell my students, think of this as 3 parts. The part in front of the plus minus, the part behind the plus minus, and the part in the denominator. If all 3 parts have the same thing in common, factor it out. Well, all of those are divisible by 2. So if I factor a 2 out of the top, 4 divided by 2 is 2, plus or minus 2 square root of 5 divided by 2 leaves me with just square root of 5. And on the bottom, I can factor out a 2 and leave myself with a 1, so that the 2's that I factored out cross out. So I'm left with 2 plus or minus square root of 5 over 1, which is really just 2 plus or minus square root of 5. So those should be your answers, which would go up here in option A. And it says to use a comma to separate answers as needed. So I would put 2 plus square root of 5, comma, 2 minus square root of 5 for my answer and select A. Okay, so that takes us to the end. I would like to remind everyone of the feedback survey. I'll put it in the chat again. If you want to fill that out, we'd greatly appreciate it. And as we mentioned, number 19 is very similar to number 20. And I know that on Saturday, at this week 3 session on Saturday in this recording, it was discussed, problem 20 and 19. So if you want to go back to that, you can. And then tomorrow, if you're not taking your test yet, from 1:30 to 2:30, we have another review session. And it's most likely, depending on what questions the students have, that other questions will be discussed, because that lecturer will again take student questions first, but then if nobody has any specific ones, she'll go over problems that I haven't gone over and that the lecturer, Paul, on Saturday had not gone over. So you get a wide variety of them. If you are testing at the end of the week, you can go back and watch any of the recordings. So thanks so much. Good luck, and feel free to come to any of the other sessions. And if you have any questions, you want to stick around after I end the recording, I'm happy to answer just, a few quick questions if you have any. Good luck.